Morning, grade 8 students. I hope that you are doing well. Today is Tuesday, March 10th, 2020. In this video, we will continue solving the worksheet that I distributed for you guys before we went off. So, before we start solving, let me remind you about our lesson, Archimedes principle. As we already agreed, we have two weights. The weight of the body when it's in air, it's called the real weight, and the weight of the body when it's completely immersed in liquid, it is called the apparent weight. If you notice that the weight decreased from 4 Newton to 3 Newton when the body is totally immersed in liquid, due to what is the decrease in weight? Due to the upthrust force. Define upthrust force. Upthrust force is the force exerted by the liquid on the body. How do you calculate the value or the magnitude of the upthrust force? By using this formula, F equals to weight real minus weight apparent. So upthrust force is equal to weight real minus weight apparent. Now let's move on to the statement of Archimedes' principle. Any body totally or partially immersed in liquid is subjected to a vertical upthrust force of magnitude equals to the weight of displaced liquid. So the magnitude of the upthrust force is equal to the magnitude of the weight of displaced liquid. How do we calculate the magnitude of the weight of displaced liquid? We use this formula, mass of displaced liquid times gravity. If mass of displaced liquid is not given, we use Archimedes' main formula, which is F is equal to rho liquid times VI times gravity. Rho liquid stands for density of the liquid, VI stands for volume of immersed part of the body, and G stands for gravity. Please, I want you to keep in mind the following notes. They are very important. A. When the body is totally immersed in liquid, we can say that the volume of the immersed part of the body equals to the volume of the body equals to the volume of displaced liquid. But when the body is partially immersed in liquid, we can only say that the volume of the immersed part of the body is equal to the volume of the displaced liquid, but it's different from the volume of the body. When the body is partially immersed in liquid, weight apparent is equal to 0. D. To know if the body will sink or float, we have to compare weight real with F or rho liquid with rho body. Rho liquid stands for the density of the liquid. Rho body stands for the density of the body. For more information on this note, please open your copybooks and review the written notes. E. The ratio VI over VB shows how much of the body is below the surface of the liquid. We multiply it by 100 to get the answer in percentage. For example, the ratio VI over VB equals to 0.6. We multiply it by 100, we will get 60%. This ratio shows that 60% of the body is below the surface of the liquid. Now, guys, I want you to bring worksheet number 4 and open on the second exercise and try to solve it alone. It should take around 15 to 20 minutes with you guys. I'm waiting. Pause the video and start solving. When we solve a physics exercise, we have to read the exercise carefully and we have to pick out the given. An iceberg is a huge block of ice that floats on the surface of water. In order to show the dangers of icebergs in marine navigation, we take a piece of ice of mass 0.27 kilograms and of volume 3 times 10 minus 4 meter cube. Given the density of water equal to 1000 kilogram per meter cube and gravity equals to 10 Newton per kilogram. So we picked out the given. Now we have to start solving the exercise. Number 1. We immerse the piece of ice completely in water and we release it. We have to keep in mind that in this part, the body is totally immersed in liquid. So we can say that VI equals to VB equals to the volume of displaced liquid. Part A. Name and classify the forces acting on the piece of ice. Since the piece of ice is in water, the forces acting on it are its weight and the upthrust force. Now I have to classify them. Weight is classified as a force acting from a distance. The upthrust forces are classified as a contact force. B. Determine the value of each force. In this part, I have to calculate the value of the weight real and the value of the upthrust force. How do we calculate the value of the weight real? By applying this formula, mass of the body times gravity. The mass is given, gravity is given. We multiply them by each other to get the answer. So it's equal to 2.7 Newton. Now I have to find the magnitude of the upthrust force or the value of the upthrust force. After we apply the Archimedes formula, rho liquid times VI times gravity. Rho liquid stands for the density of the liquid, VI stands for the volume of immersed part of the body, G stands for gravity. But in number 1, they said that the body is totally immersed in liquid. So we can say VI equals to VB equals to 3 times 10 minus 4 meter cube. We put the numbers 1000 times t times 10 minus 4 times 10. We will get the final answer, which is equal to 3 Newton. Part C. The piece of ice starts rising in water. Why? I have to compare the upthrust force with weight reel. Since upthrust force is greater than weight reel, the piece of ice starts rising in water. Number 2. The piece of ice floats in equilibrium on the surface of water. Please underline the word equilibrium. Part A. Give the condition of equilibrium of the piece of ice. Since the forces acting on the piece of ice are its weight and the upthrust force, the condition of equilibrium is written as W vector plus F vector equal to 0 vector, W vector equal to minus F vector, which means they have the opposite direction, W equals to F equals to mass times gravity, which means they have the same magnitude. Part B, I have to determine the volume VI of the immersed part. So I have to calculate VI. We use the formula of VI. It's equal to F over rho liquid times gravity. But since the piece of ice floats in equilibrium on the surface of water, F becomes equal to W. So F becomes 2.7 Newton. Okay, so we replace F by 2.7 Newton, rho liquid by 1000, gravity by 10. We will get the answer 2.7 times 10 minus 4 meter cube. Part 3. A. I have to calculate the ratio VI over VB. VI equals to 2.7 times 10 minus 4 meter cube. VB equals to 3 times 10 minus 4 meter cube. So VI over VB it's equal to 2.7 times 10 minus 4 meter cube over 3 times 10 minus 4 meter cube. It's equal to 0.9. We multiplied by 100 to get the answer in percentage. So it's equal to 90%. Part B. The ratio VI over VB shows an evidence of the danger of icebergs. Explain why. It is dangerous since 90% of the iceberg is below the surface of the water, which means that only 10% of the iceberg is visible to the marines. 4. A. Determine the density of ice. Density of ice means that I have to calculate the density of the body. How do you calculate the density of the body? By applying this formula, mass of the body over volume of the body. Mass of the body is given, volume of the body is given. We divide them. We divide 0.27 by 3 times 10 minus 3 meter cube. We will get the answer 900 kilogram per meter cube. Part B, compare it to the density of water. Now I have to compare density of the liquid, density of the body. Since density of the liquid is greater than density of the body will float on the surface of the liquid. That's it for today, guys. If you have any question, please don't hesitate to contact me. I hope to see you all soon. Thank you for your